You know that moment you're pinned down in a shooter and the enemy squad is just perfectly flanking you, laying down covering fire. They even seem to be talking to each other. Or maybe you're in a stealth game and a guard hears the tiniest little noise and comes to investigate, just like a real person would. We just kind of say, wow, that's some smart AI. But how? How do they actually do that? What is going on inside the digital head of a video game character? Well, today we're going to peek behind the curtain and build one of these brains from scratch.
I mean, really think about it for a second. How does that soldier know you're aiming at them? How do they decide in a split second that the burned out car over there is a way better spot to hide behind than that low wall? It feels like they're thinking, right? Like they're strategizing. But what if I told you it's all a brilliant, high-speed illusion? So, to really get how this all works, we're going to build our very own non-player character, an NPC, right from the ground up. We're going to add the layers of its so-called brain one by one, and you'll see how all these simple systems start to stack up to create some incredibly complex and believable behavior. Okay, this is probably the single most important thing to get about game AI. It's not one giant all-knowing consciousness humming away in there. Nope. It's more like a stack of highly specialized little programs. You've got one part that handles seeing the world, another that handles just moving around, and a totally different part that decides what to do. So let's start at the bottom of that stack, the senses. Right. Before an AI can do a single thing, it has to be able to gather information. It needs a way to see, hear, and basically sense the virtual world that it lives in. This is the entire connection between the game and the character's brain. So, when an AI programmer talks about perception, they mean something way broader than just eyes and ears. Perception could be knowing its own health is low or checking how much ammo it has left. It could even be getting a radio call from a teammate across the map. Basically, it's every single piece of data the AI uses to figure out its next move. And, this whole idea of sense simulation was a total game changer. Think about it. In really old games, enemies just sort of magically knew where you were all the time. But pioneers like GoldenEye and Thief made their AI rely on what it could actually see and hear. And suddenly, you, the player, had to worry about being spotted or making too much noise or even leaving a body where another guard might find it. It just created this whole new level of immersion. Okay, so our character has senses now. It sees the player, it hears a gunshot, so what next? It needs to move. And let me tell you, just getting from point A to point B in a complicated 3D world is a huge challenge. It's the next layer we have to build for our NPC's brain. Turns out movement is really a two-part problem. First, you've got pathfinding. This is the big picture stuff. It's like your GPS. If our guy needs to get from the barracks to the watchtower, pathfinding figures out the best overall route. But then you have steering behaviors. This is the moment-to-moment stuff, like swerving to avoid bumping into people on a crowded sidewalk. It's what keeps the character from face-planting into a wall along that path. So, pathfinding looks at a simplified map of the level and uses a clever algorithm to find the shortest, most efficient path. The most famous one is called A-Star, and it is fantastic at quickly finding a route that actually makes sense. So your character doesn't try to go from the kitchen to the living room by running through the attic first. Once the Pathfinder gives the AI a direction, these little steering behaviors take over. They are the simple, fundamental building blocks of all complex motion. Seek just gets it moving, collision avoidance keeps it from crashing into things, and Arrive makes sure it slows down so it doesn't overshoot its target. You blend these simple little rules together, and boom, you get fluid, believable movement. So let's put it all together. The Big Brain Pathfinder says, okay, here's the route. Your first stop is that point over there. Then the character uses all its little steering behaviors to move towards that point. When it gets there, the Pathfinder gives it the next point on the map, and the whole process just repeats. It's this beautiful little dance between high-level strategy and low-level action. All right, our character can see the world and it can move through it. Now we're finally moving up the stack to the real brain of the operation. This is where the AI decides what it actually wants to do with its life. This is the million-dollar question, right? When an AI spots you, what is the logic that makes it charge at you instead of running for cover? Well, in the past, developers used some pretty simple systems, but modern games need a lot more flexibility. And that's where a really powerful tool called a behavior tree comes in. The best way to think of a behavior tree is like a flowchart for making decisions. It's a really clean way for a programmer to lay out a character's priorities.
The AI starts right at the top of the tree and just works its way down, trying out different branches of behavior until it finds one that actually makes sense for the situation it's in.
Let's actually follow the AI's thought process here. It starts at the top. First priority, attack the player. Okay, let's check the conditions. Is the player visible? Yep. Is my weapon loaded? Whoops, no, I need to reload. So that entire attack plan fails. Because it failed, the tree automatically moves to its next priority, find cover. It checks those conditions. If they work, off it goes to hide. And if absolutely everything else fails, it just falls back to its default action, which is to just patrol around. It's this beautiful, cascading system of plans and backup plans. So we've built a pretty smart individual character, but let's be honest, the real magic in modern games happens when these individuals start working together as a coordinated squad. So how does a squad decide who goes where? You're gonna love this. They do math. The AI is constantly analyzing the battlefield, giving scores to different locations. Like here, the old crate offers amazing cover, but you can't see much from there. The burned car is a bit more exposed, but it has a great line of sight. By calculating a final tactical value for each spot, the AI squad can make smart decisions. This simple math is exactly how one soldier knows to lay down suppressing fire from the burned car, while another one flanks you from the old crate. It's how they create that feeling of a coordinated attack. And to move around as a single unit, they use formations. It's such a clever system. Basically, a leader determines the general direction, and every other squad member is just assigned a virtual slot to stay relative to that leader. Then their own individual steering behaviors kick in to keep them in their assigned spot as the whole group moves. This is how you get a whole squad that can sweep through a building as a tight, cohesive team. It looks so complex, but it's built on those simple rules we already talked about. And this quote really nails how modern games are made. Developers aren't starting from scratch and reinventing the wheel for every single enemy. Why would they? They're using this powerful toolkit of tried and true systems for perception, movement, and decision-making that we've just been exploring. But here's the part that is just truly mind-boggling. Every single one of those perception checks, every pathfinding calculation, every branch of a behavior tree, for every single character on screen, all of it has to happen in a tiny fraction of a second. Game AI has to be not just smart, but unbelievably, ridiculously efficient so it doesn't slow the whole game down to a crawl. And that's the secret, really. It's not about creating true consciousness in a machine. It's about layering these different, specialized systems, perception, movement, decision-making, tactics, to build a puppet that is so convincing, so responsive that for a moment, we absolutely believe it's alive. And that brings us to what's next. We've seen how sophisticated these rule-based systems have become, but there is a whole new frontier just on the horizon. You see, everything we've talked about today is largely handcrafted by developers. They write the rules. But what happens when we throw machine learning into the mix? What happens when an AI doesn't just follow its programming, but actually learns from every single fight, adapts to your personal playstyle, and starts creating strategies that no programmer ever even thought of? That, right there, is the next great leap, and it's probably going to change gaming forever.